Hello, Math 2. This is your guys' practice test number 2. So let's take a look at the first one. So for a lot of these problems, we have to solve for x and y, or a combination of the two. Okay, right here, you guys. Right there, I noticed that's a linear pair, which means those two angles are going to add to 180. So 2x plus 100 is going to equal 180. And then we just solve from here. Subtract 100 from both sides and divide both sides by 2. So we're going to get 40. So we have x is equal to 40. So let's write that down. All right, next. Notice, do you guys notice that that these two sides are congruent? Now, recall, when a triangle has two congruent sides, that means it's an isosceles triangle. And if we have an isosceles triangle, that means the two base angles are congruent to each other. So that's why we can also say that this is also 2x. So we know it's 2x. Now I'm curious, since we just found the value of x, now we can find out what these angle measurements are. So the angle measurements for this one is 2 times 40, which is just 80. So both of these angles are going to be 80 degrees. So if we wrote down our equation, remember, a whole triangle adds up to 180, right? And since we know 2x is now 80, we have 80 plus 80, because there's two of them, plus y is equal to 180. Triangle sum theorem, that's how many, what the sum of interior angles of a triangle are. It adds up to 180. So we have 160 plus y is equal to 180 minus 160 from both sides. And we have y is equal to 20. So there's the explanation for number 1, you guys. Okay, number 2. This is a 30, 60, 90 degree triangle, a special right triangle, and remember, you guys have to recall your guys' ratios. So from hypotenuse to short leg, it is divide by 2. And from short leg to long leg, it is multiply by rad 3. And then vice versa, long leg to short leg, divide by rad 3. Short leg to hypotenuse, multiply by 2. Here's the hypotenuse, because it's the one across from the 90 degree angle. Now, does everyone see that 30 degrees? That's the smaller angle, which means the side length across from the smaller angle is the short leg. And the side length across from the bigger angle is the long leg. So now we can solve for this. So we have the long leg right here. This is the long leg, which means to get from long leg to short leg, it is divide by rad 3. So divide this by rad 3, and we're going to get 3. So x is equal to 3. And now we're going from short leg to hypotenuse. So short leg to hypotenuse is simply just multiplying it by 2. And we're going to get 6. So it's important that you guys remember that ratio. Over here we got a 45, 45, 90, which means you guys need to remember this ratio. Hypotenuse and the leg. Here's hypotenuse, and here are the two legs. So from hypotenuse to leg, you gotta divide by rad 2, and from leg to hypotenuse, you have to multiply by rad 2. So we have the hypotenuse, so we need to get from hypotenuse to leg. So we got 10 rad 2 divided by rad 2, which is equal to 10. and we are gonna get 10 here. And since both the legs are the same, because 45 and 45 are the same angle measurement, we got 10 here as well. All right, number 4. These, we have parallel lines cut by transversal. These two angles are congruent. These two angles are congruent. They're corresponding angles and they're equal to each other. So 9x plus 20 is equal to 10x plus 5. I'm just going to subtract 9x from both sides. Minus 5 from both sides. And we got 15. X is equal to 15. Okay, number 5. Now, this has to deal with the sum of interior angles of a polygon, you guys. If you don't recall, this will give you, that formula will give you the sum of the interior angles of any polygon. N is the number of sides, and we have 5 sides here, so 180. And then 5 minus 2, which is simply 180 times 3, which is 540. Okay, you're not done. 540 represents the sum of the interior angles of this polygon. So that means all of these interior angles add up to 540. So 7x plus 3x plus 100 plus 140 plus 160 is equal to 540. Collect like terms, we're going to get 10x plus 400 is equal to 540. Subtract both sides by 400. 10x is equal to 140. Divide both by 10, and you should get x is equal to 14. Okay, number 6. Now, all of these angle measurements, these are all exterior angles. All of these, they're all exterior angles. For any polygon, the sum of the exterior angles for any polygon adds up to 360. So all of these angles, x, 2x, 50, 70, 80, and 40, those all add up to 360 because they're all exterior angles. So collect like terms, so 3x plus 240 is equal to 360. Subtract both sides by 240. 3x is equal to 120. Divide both by 3, and x is going to equal to 40. Okay. Number 7. Okay, this is a parallelogram. Number 7 is a parallelogram, which means we know 4 characteristics of parallelogram. One characteristic is all opposite sides of a parallelogram are congruent, which means 3x plus 10 is equal to the opposite side, which is 2x plus 20. You also know 10y minus 20. The opposite side of that one is equal to 5y minus 5. And you guys just solve. Minus 10 from both sides. Minus 2x from both sides. And we're going to get x is equal to 10. For this one, I'm going to subtract 5y from both sides. And then I'm going to add 20 to both sides. Divide both sides by 5, and we're going to get y is equal to 3. Okay, now let's go to number 8. Number 8, we have a parallelogram. Consecutive sides of a parallelogram add up to 180 because they're supplementary. So 8x plus 40 plus 12x plus 20 is equal to 180. We're going to get 20x plus 160. Ooh, that's a 40. 20x plus 60 is equal to 180. Subtract 60 from both sides. Divide both sides by 20. So x is going to equal to 6. Number 9. Okay, so multiple things we can do right here. Now, one thing I would do is, in a parallelogram, opposite angles are congruent to each other, which means x minus 30 angle is going to equal to 2x minus 100. Going to subtract 2x from both sides. Negative x minus 30 is equal to negative 100. Add 30 to both sides. Negative x is equal to negative 70. Divide both sides by negative 1. X is equal to 70. Now, I need to know what this angle measurement is. So I'm going to see what, if x is equal to 70, we know that angle measurement's going to be 70 minus 30, which is 40 degrees. So, since we know now that's 40 degrees, remember, consecutive angles of a parallelogram are supplementary, which means they add up to 180. So, 40 plus y is equal to 180. Subtract 40 from both sides. Y is going to equal to 140 degrees. Alright. Number 10. Okay, we have a triangle, and it's being intersected by a pair of parallel lines, which means these sides will be proportional to one another. So, have to make a proportion with those sides. 12 over 6 is equal to x plus 2 over 4. Cross multiply, we're going to get 48 is equal to 6 times x, which is 6x plus 12. Minus 12, minus 12. Going to move this over here. 36 is equal to 6x. Divide both sides by 6. X is equal to 6. Number 11. Okay, so same thing, but remember, the proportion is with these side lengths. We have to figure out what that side length is. So, the whole minus the part is that side length. So, 15 minus x. That's going to give you guys that small side length right there. Now we can set up a proportion. 4 over 8 is equal to x over 15 minus x. Cross multiply. So we're going to get 4 out of 15 minus x is equal to 8x. 60 minus 4x equals 8x. I'm just going to add 4x to both sides. 60 is equal to 12x. Divide both sides by 12, and x is going to equal to, or 5 is going to equal to x. So we got 5. That is our triangle proportionality theorem, okay? Number 12. Set up a proportion. 2x plus 8 over 3x is equal to 4 over 2. Cross multiply. 2 times 2x plus 8 is equal to 12x. Distribute this 2. We get 4x plus 16 equals 12x. Subtract 4x from both sides. 16 is equal to 8x. Divide both sides by 8. 2 is going to equal to x. So x is equal to 2. Alright, number 13. Are the triangles similar? If so, explain. So I see we have this triangle, number 13, right there. So, in order to prove triangles are similar, we either have the side-side-side similarity theorem, we have the angle-angle similarity theorem, or we have the side-angle-side similarity theorem. Now, these look to be like the side-side-side similarity theorem, which means in order to prove triangles similar through side-side-side, They have to be proportional. So let's see. 10 over 15. Is that equal to 20 over 30? And is that equal to 16 over 24? I'll do this in a different color. Okay, 10 over 15, I know I can divide both sides by, I can divide top and bottom by 5. 20 over 30, I know I can divide both by 10. And 16 over 24, I know I can divide top and bottom by 8. So, 10 divided by 5 and 15, we're going to get 2/3 here, which equals, we're going to get 2/3 there, and we're going to equal 2/3 there. So, all of these sides are proportional to one another, which means these triangles are similar. Yes, because side, side, side similarity theorem. All the sides are proportional to one another. Okay, let's look at 14. Alright, so let's see if they're similar. Let's see if they have sides proportional, and let's see if, well, let's just see what we have. So 1 over 2, is that equal to 3 over 6? Well, it looks to be so, because 1/2 equals 1/2. So you know you have a pair of sides, two pairs of sides that are similar. Now look at the angle. Angle A is not congruent to angle D, which means no, not similar. Now, if those angles were congruent, then we would have side angle side similarity theorem. But since those angles aren't congruent, that means that we cannot prove it by side angle side. So those are not similar. Okay, 15. 15 is a trickier one because we know that these two angles are congruent. Now, this one has 75 and this one has 85. So let's just use the triangle sum theorem to see what this other angle is right here. Well, 20 plus 75, we'll just label that x, plus x is equal to 180. 95 plus x is equal to 180. Subtract 95 from both and we're going to get 85. So this angle is 85 degrees. Which means that this angle is congruent with that angle, and this angle is congruent with this angle. Which means we have the angle-angle similarity theorem, because they're both congruent. So that is a big yes, they are similar. Alright, 16. What additional information do you need to prove that the triangles are congruent by angle side angle? So we have a pair of sides congruent. So these are S, right? We have a pair of sides congruent. Now, is there anything else we can say? Well, I see that these angles are congruent because they're vertical angles. So that means we have a pair of angles congruent to each other. So that's all that's given to us. Now let's read the directions again. What additional information do you need to prove that the triangles are congruent by angle side angle? Angle side, which means this angle right here has to be congruent in order to fulfill the angle side angle. Which means on the other triangle, angle side, this one has to be congruent in order for it to be angle side angle. Which means what additional information we need? We need to know that angle A has to be congruent to angle D in order to fulfill that it's angle side angle. 17. Okay, so we have BD perpendicular AC. That means we have 90 degrees there. Check. AB is congruent to CB. So that's given to us. So let's just write that down. That's congruent to that. Are these triangles congruent to each other? If so, explain why. Well, here's BD. We know that's congruent to itself. So, what I notice is we have a 90-degree angle, which means we have two right triangles, and these are the hypotenuses, and these are the legs. So that means this triangle is these two triangles are congruent to each other because of the hypotenuse leg congruence theorem. A pair of hypotenuses are congruent to each other, and a pair of legs are congruent to each other, and we have 90 degrees, so hypotenuse leg congruence theorem. Alright, so here's 18. Alright, we have a given statement. C is the midpoint of AE and BD. So, from that, C is the midpoint of both of these long segments. C is in the middle, which means those two smaller segments are congruent to each other. So, we'll just focus on C as the midpoint of AE. I'll do a highlighter. Here's AE, which means since C is in the midpoint, we can say, or we know, AC is congruent to CE. C is also the midpoint of this side length as well, which means we know that BC is going to be congruent to CD. Right? When you guys think of midpoint, it's in the middle, which means the two segments of the bigger one are going to be congruent. So let's go to our statements. This is given. Okay, angle BCA is congruent to angle DCE. So they're saying that angle is congruent to that one because of vertical angles are congruent. And why are the triangles congruent to each other now? Well, sides, angle, sides. So side, angle, side. Side, angle, side. Now, since we proved that the triangles are congruent to each other, every single corresponding part of one triangle is congruent to every single part of another triangle. So, the thing we have to prove is that this side is congruent to that side. Well, since we proved triangles congruent to each other, now we can say corresponding parts of congruent triangles are congruent. CPCTC. Last one, 19. Okay, given AB congruent to D, writing that down. Angle B congruent to angle E, writing that down. So 1, we got a given statement. Alright, it says angle BCA is congruent to DCE. These are these angles. That's vertical angles are congruent. Now we can say the triangles are congruent to each other because we got angle, angle, side. Angle, angle, side. Angle, angle, side. And since we have triangles that are congruent to each other, every single part of one triangle is congruent to every single part of another triangle. So AC is I'll do a different color. AC is congruent to AC is congruent to DC because of CPCTC. So you guys make sure you study up on this because the test is going to look very similar to most of these problems and it's going to be multiple choice. So good luck studying and see you guys on or soon.